Greetings. Welcome back to trigonometric function. In this module, we are going to do the solution of a triangles, the problems using cosine rule. Problem states what? A square into sine of b minus c upon sine b plus sine c plus b square into sine of c minus a upon sine c plus sine a plus c square into sine of a minus b upon sine a plus sine b should be equal to 0. Considering a square into sine of b minus c upon sine b plus sine c. Now, in this case, we know that sine of b minus c can be expanded as sine b cos c minus cos b sine c upon sine b plus sine c. Over here, we can apply the cosine rule as well as sine rule. We can apply sine rule in sine b and sine c. Similarly, the cosine rule can be applied in cos c and cos b. So, after applying the sine and the cosine rule, equation would be a square into sine b would become bk, cos c would be a square plus b square minus c square upon 2ab minus of sine c would be ck, cos b would be c square plus a square minus b square upon 2ac, the whole upon sine b plus sine c. In that case, sine b would be replaced by bk, sine c would be replaced by ck. If you have observed, in first value, the b and b gets cancelled. In second, c and c gets cancelled. K is common. Also, 2a is common. And also k is common in denominator. So, the equation can be a square into k upon 2a into a square plus b square minus c square minus c square minus a square plus b square, the whole upon k into b plus c. In this case, a and a square gets cancelled, k and k gets cancelled. Also, a square gets cancelled in the brackets. So, the equation would be now a upon b plus c into 1 upon 2 into a square plus b square minus c square minus c square minus a square plus b square. Again, a square and minus a square are getting cancelled. So, the equation which you have is a upon b plus c into 1 by 2 into 2 times of b square minus 2 times of c square. If we keep the 2 common, equation would be a upon b plus c into 1 by 2 into 2 of b square minus c square. So if 2 and 2 gets cancelled, the equation would be a upon b plus c into b plus c into b minus c. As we are already aware about, a square minus b square is a plus b into a minus b. In this case, the b plus c and b plus c gets cancelled. So the outcome is a into b minus c. So I can say a square into sine of b minus c upon sine b plus sine c gives us a into b minus c. So similarly, for b square sine of c minus a upon sine c plus sine a, we would get b into c minus a. And for c square into sine of a minus b upon sine a plus sine b, we would get c into a minus b. So, our required LHS is a square sine of b minus c upon sine b plus sine c plus b square sine c minus a upon sine c plus sine a plus c square sine of a minus b upon sine a plus sine b. In that case, equation would be a into b minus c plus b into c minus a plus c into a minus b. After expansion, AB gets cancelled, AC gets cancelled, and also BC gets cancelled. So the answer is 0. So hence I can say we have got our required proof in this case. Also, students, mark this problem very important. The only reason is that this question is asked several times in the papers. Moving ahead with the other question. In triangle ABC, if cos A upon A is equal to cos B upon B, then show that it is an isosceles triangle. The solution states if cos A upon A is equal to cos B upon B, then we also know that by sine rule, cos A upon A would be replaced by A sin A and B would be replaced by K sin B. In that case, cos A upon sin A would be equal to cos B upon sin B. So the equation would be sin A cos B is equal to cos A sin B. So we get sin A cos B minus cos A sin B, which is equal to 0. We already have the standard formula, that is sin of A minus B, which is equal to 0. Therefore, I say A minus B has to be equal to 0. If A minus B is 0, A is equal to B. Hence, triangle ABC is an isosceles triangle. Thank you.